You will remember that yesterday we went over 3 skills and we put them into our IND. We have the solving a simpler problem, which is like questions 19 through 21. We have questions with a distributive property like 22 through 24. And we have questions like factoring 27 through 32. On page 491, we're going to kind of go through some of these. We're going to do a couple together, and then I want you to try some on your own. So let's start with question number 20. Pencils in hand, ready to go with me. On number 20, we want to solve a simpler problem. So which part do we want to split up, the 11 or the 27? 27. The 27. So we're going to take this 11, and we're going to remove it, and we're going to break 27 into what 2 factors? 20 plus 7. Very good. Now we're just going to share like we do with the distributive property. So 11 times 20 plus 11 times 7. We're just sharing these. Remember that plus sign stays the same because we had that in between our factors there. What is 11 times 2? 22 plus a 0? 220. Plus, what's 11 times 7? 77. That's a much simpler problem for us to solve. So 220 plus 77? 297. Okay, now we can do that with fractions, we can do that with decimals. Solving the simpler problem helps us to break it down. So what I would like for you to do is to go ahead, you're going to pause the video, okay, and I want you to work on question number 21. Okay, let's take a look at now how to solve that 21. Are we going to break apart the 3 or the 3.9? 3.9. So we're going to take 3 times 3 plus 0.9. That 3 plus 0.9 is the same as 3.9. We're not changing the value, just its form. Now we need to distribute this 3. So 3 times 3 plus 3 times 9/10. So 3 times 3 gives us 9 plus, what's 3 times 9? 27. So 3 times 9 is 27, but I have to move my decimal back 1 spot. 2.7, which gives me 11 and 7 tenths. Does that make sense?
Yes.
Okay, let's try the next set. Now we're going to use the distributive property with some variables. So in the distributive property, what are we really doing? What's kind of the concept, the key of the distributive property? Peyton? Sharing equally. So in this first question, number 22, we're sharing what equally? The 4. So this 4 we have to share with every term inside our parentheses. So 4 times x, you don't have to write out this step, but I want to show it to you, plus 4 times 2. Doesn't that step look a whole lot like this middle step that we did up here?
Yes.
Okay, so what we're doing is we're using the distributive property in these solving simpler problems and in these new problems. So what is 4 times x? 4x plus, what's 4 times 2? 8. Can we combine 4x and 8? No. They're unlike terms. One's a constant, one has variables. So that is my simplified expression. Go ahead now and pause the video. I want you to do questions 23 and 24. Go. Okay, let's take a look now at question 23. We're sharing the 3 with every other term inside our parentheses. So this really means 3 times x plus 3 times 7. You don't necessarily have to write this step, but if it helps you, by all means do so. So 3 times x gives you 3x. And 3 times 7 gave you 21. Can I combine these two terms? No, those are unlike terms. So we just get 3x plus 21. On 24, what are we sharing? The 5 with all of our other terms. A good question came up. How can I combine a 5 and 2x? Well, through multiplication, can we do 5 times 2?
Yes.
And then we still have the x there. So it's okay in multiplication to combine those terms. Okay, they're not unlike with multiplication because this really means I have 5 2x's, which 5 2x's gives me what? 10x. Plus, we're sharing the 5 with the 7. 5 times 7 gives you 35. Are those like terms?
No.
No, I can't add them together. Remember, back to our McDonald's combo meal lesson? If this 10x stood for burgers and this 35 stood for Cokes, I can't combine those two things together to get one item. Gentlemen, fix it. So these are two separate terms. They can't be combined. It's as simple as it possibly can be with 10x plus 35. Okay, let's go down to our factoring. This is really the opposite of the distributive property. So go to question 27. Factoring really means undoing the distributive property. Now we don't have parentheses. We want to get it back to a form where the parentheses are there and we've pulled out its greatest common factor. So look at question 27. What's the GCF of 27 and 12? We'll pause and resume at the break. Okay, so let's resume again. What would we find as the greatest common factor of 27 and 12? 3. So if I remove 3 times what makes 27?
9.
3 times 9 plus, make sure you're doing this with me, 3 times what makes 12?
4.
3 times 4. If I take out the greatest common factor and remove it to the front of the parentheses, what's left in the inside? 9 plus, because my sign here was plus, right? 9 plus 4. Let's check and see if this actually works. What's 3 times 9? 27, that's what we got there. What's 3 times 4? 12, that's what we started with. So this is correct. Okay, look at number 30. Let's look at it with variables now. What would the GCF of 2x and 8 be? 2. So 2 times what makes 2x? 2 times x, or 1x. We don't have to write the 1, it's just assumed. Plus 2 times what makes 8?
4.
2 times 4. If I remove that GCF and put it in front of the parentheses, what's left? X plus 4. Let's check it. 2 times x?
2x.
So we started with plus 2 times 4?
8.
Is that what we started with?
Yep.
So this factored expression is correct. I want you to go ahead and pause the video at this time, and I want you to do 28, 29, 31, and 32.
By yourself.
Go.
By yourself.
Okay, let's take a look at these 4 problems and just check in and see if we have any questions. What is the GCF of 12 and 36? 12. So 12 times what makes 12? 12 times 1 plus 12 times what makes 36?
3.
12 times 3. So if I remove my GCF, put it in front of the parentheses, what's left inside? 1 plus 3. Very good. What's the GCF of 16 and 20?
4.
4. 4 times what makes 16?
4.
4 times 4 plus 4 times what makes 20?
5.
4 times 5. If I remove my GCF, what's left inside?
4 plus 5.
4 plus 5. Very good. On 31, what is my GCF of 30 and 12x?
6.
So 6 times what makes 30?
5.
6 times 5 plus 6 times what makes 12x? 2x. Don't forget that x. That's really important to make 12x. If we just have a 2 here, 6 times 2 only makes 12. And we need a 12x there. So remove our GCF of 6. What's left inside?
5 plus 2.
5 plus 2x. If I check it, what's 6 times 5? 30. That's what we started with. What's 6 times 2x?
10.
12x. So that's what we started with. Means we're correct. We're factoring. What's the GCF of 42x and 49?
7.
7. So 7 times what makes 6x?
6.
Sorry, I said 6x. I'm sorry. 7 times what makes 49?
7.
It's been a long week. 7 removed as our common factor leaves me with 6x plus 7. Very good. Any questions about now how to factor an expression or distribute or simplify? How many would say that that was helpful? You feel a little bit more confident in those 3 skills? Okay, good. Then what I would like for you to do is to turn in your book to 496, is that right?
Yeah, that's
496 will be the next lesson, lesson 7. No, 495, how about? Okay, turn to 495. I want you to complete the what you'll learn at the top of the page. By yourself? Go quick. What are some things that you wrote down that would be listed as headings for this lesson? Brock?
Addition.
That would be a real world thing. We need some headings. What we're going to learn about. Sydney?
Simplifying expressions with one variable.
Simplifying expressions with one variable. And what else, Toby?
simplify expressions with
Simplify expressions with two variables. Now, take a look at this vocabulary startup. This should look very familiar to us. We've already talked about these vocabulary words. A term is, remember, any part in the algebraic expression. So if we look here at this expression, a term would be 3x, a term would be 7, and a term would be x. We've also talked about coefficients. The coefficients are the numbers in front of the variable, okay, the numerical factor. So in this term here, the coefficient would be the 3. It's the number in front of that variable. We've talked about constants. Constants are just plain and simply the numbers. It's a number that doesn't have a variable, it's just a plain regular number. And then like terms would be terms that have the same variable or two constants. So in this expression, 3x and x would be considered like terms. Look at the graphic organizer. Let's see if we can fill in the correct vocabulary there. What word would we put that describes all three of these? What would we use there? Terms. Very good. What about this one that's just describing the 9?
Constant.
Constant. And what about this one that's showing those two terms there? Brooke? Like terms. And yes, they do, in that particular case, also contain variables. And they both have coefficients, don't they? What's the coefficient in the first term? 4. What's the coefficient in the second term? 2. Does the 9 have a coefficient? No, because it's a constant. Turn the page to page 496. Now this is just a matter of simplifying expressions by combining like terms. We've done a little bit of this already in your IND. We've done a little bit of this even when we talked about the distributive property yesterday. So look at the first one. This particular expression, when I have 4 smashed up next to 6x, what does that mean in algebra?
multiply.
It means to multiply. This really means that I have 4 6x's. Well, if I combine 4 6x's, what would that equal? 24x. And this is its simplified version. So when we talked about those McDonald's combo meals, and we talked about giving all of those things, so 6 burgers and 4 Cokes and then 2 more burgers and then another Coke, we don't want to have on the tray, we want to know that if there are 6 burgers plus 4 Cokes plus 2 burgers, I'm going to put 8 burgers on the tray. I want to combine anything that's alike to make the simplest tray in the McDonald's reference or the simplest expression possible. So it's not a really long expression, it has everything combined in it that is possible. So let's look through these got it's together. If I have 3 times x times 11, what would I get when I simplify that expression? Paige? 33x. Very good. We combine the 3 times 11 to make 33, and the x is still there. It has to be multiplied. It can't be combined with the 33. Now, it looks like it's combined because it's smashed together, right? But that still means 33 times x, doesn't it? Yeah. What about letter B? I have an x, and an x, and an x. Alex, what do you think?
X?
I have 1x plus another x plus another x. 3x. Very good. Total, I have 3 x's. We can think about those x's like candy bars. I have 1 candy bar, I have another candy bar, I have another candy bar. Total, I have 3 candy bars. Look at letter C. What are my like terms in letter C? Sydney?
7.
Like terms. That's just a coefficient. What are my like terms? X and what?
7.
Not just 7.
8.
No. What's the other thing that's like it? Like terms have the same variables or their constants. What can be combined in that expression? Help her out, Laurel.
The 7x times the plus 14x.
Now, is it times or is it added?
Plus
So we have a 7x and we have another x. That makes how many x's? 7x and another x.
2.
I have 7 of something, I'm adding another one.
8.
8. I have 8 x's. What else is left?
7 plus 8.
Plus 8. We already combined the 7x and the x. So we just have 8x plus 8. Do you see why?
Yeah,
Okay, there's a variable. You're right. We can't combine those because one's a constant and one has a variable. Let's try another one. In your margin, I want you to write down this problem. And let's do a letter C. Okay, once you have those written down in your margin, I want you to go ahead and pause the video and try those on your own. Okay, let's take a look at these 3 problems that I created for you. In letter A, we're sharing really this 14 with 3y. So that really means 14 times 3y. Do you agree?
Yep.
We can't really multiply 14 times the y, but we can multiply 14 times 3. What's 14 times 3?
42.
So this equals 42y. That's as simple as it can get. Does that make sense? Okay, look at the letter B. That's just the distributive property. We're sharing the 5 again. So 5 times 4m gives you 20m. Share the 5 times 4, we get plus 20. Can we combine these terms? No. One is a variable, one's a constant. And 20m plus 20. Look at letter C. What like terms do we have in letter C? Laurel?
6m plus 7m.
Good. 6m plus 7m gives me 13m. Can we combine anything else? No, because we can't combine variables that are different because they represent something different. So we have 13m plus 2c plus 8. Would the order of that expression matter? No, because it's addition, which is commutative if it were 2, or associative if we're talking about 3. What questions do we have about simplifying those expressions? What doesn't make sense, or how can I clear up what we're struggling with there? Any other thing on it?
Like number C.
Okay. Do you agree that both of these are m's?
Yeah.
Okay, so this would be like having burgers and burgers. I can combine burgers together and get more burgers. But this is like having Cokes with 2c. So I can't combine anything, I can't combine the Cokes and the burgers because they're 2 different things. And then that 8 represents something totally different, like fries. So I can't combine the fries with the Cokes with the burgers. So this right here is as simple as it can get. Does that make sense?
Yeah.
Okay?
Well, no.
Okay. Let's look at this word problem. I need your pencils in hand. This, 6th graders, is probably the toughest skill of the day. If you bear with me, this will make sense. Look at number 2. It says, 3 friends will pay X dollars each for admission to the museum, plus $1 to view the mummy exhibit. Now, I'm always breaking story problems apart. Underlining, circling, marking it up. So I have 3 friends that are paying X dollars for admission and $1 for the mummy exhibit. Do you agree? Okay, so here's what I'm thinking in my head. These three friends, it's like going to the science center. You go to the science center, you pay to get in. That's your admission, right? If you pay to get in, then sometimes they have special exhibits that you have to pay an extra fee for. So 3 of those people are going to pay for admission and this new exhibit, this mummy exhibit. So those friends each are going to pay for X, that's admission, right? And what else are they paying? For $1. Do you agree that that represents what those 3 friends are buying? Now, this is the group. That group is buying the admission and the mummy exhibit. But how many people are doing that? 3 of them are doing that. Because we need 3 groups of that X plus 1. Does that make sense? Okay, everybody with me? Pencil should have that written down with me. But we're not done. That's the first 3 friends. Then it says a 4th friend will pay admission, but will not view the mummy exhibit. Write and simplify. They're asking for 2 things. What's my expression? And then simplify it. That represents the total cost. Well, right now, this represents the 3 friends. Right?
Yeah.
But we still have to pay for that 4th friend. But the 4th friend is only doing what? Only paying admission. And what does admission cost? X. So the 4th friend is just paying X. This right here represents that 4th friend. This whole expression represents the total cost for all of the friends to go to the museum. Does that make sense? This right here is also when they say to write, you just wrote your expression. There it is. You're done with step 1. Step 2 is now we just have to simplify it. Let's make it easier to manage. So we see the distributive property there, don't you?
Yeah.
So what's 3 times X? 3X. What's 3 times 1? So plus 3 plus, I still have that X.
Yeah.
Now do we have some like terms? We can combine what? Alex?
3x and the x.
Which gives us
4x.
4X plus, we have what? 3. Now this is money, so we need to put dollar signs in there. There's my simplified expression. Isn't this a whole lot simpler than this one? Yeah, wouldn't that be a lot easier to solve if they told me what X was? If they told me what X was and I put it in this expression, that would take a while, wouldn't it? It'd be a lot easier to put it in this expression down here. Porter.
I thought you said that we can't do like a variable with a
We did.
Oh.
Does that make sense?
Yeah.
Okay. With your partners, you're going to try the got it here in a second, okay? In the got it, they're referring to the same information that you were given in problem 2. So it's still X for admission and $1 for the mummy exhibit. Does that make sense? Break it apart. Try the got it here at the bottom of this page. Go. Okay, in this problem, I'm going to break it apart. Again, we're looking for the total cost of 6 friends. So we can do this one of 2 ways. There are 2 acceptable expressions. Let's say I'm going to start with the 4 friends that view the mummy exhibit and the museum, right? So what does it cost to go to getting into the museum? Getting into the museum. X. So I have 4 people that are going to pay for admission, which is X, plus what are they also paying for? Which is $1 for the mummy exhibit. How many friends have I not accounted for? 2 of them. Those 2 friends are only going to do what? Just admission. So that would be 2X. So this would be an acceptable expression. Or I could also do this. Let's say I want to start with the 6 friends. Well, 6 friends pay for admission, which is X. Didn't all 6 friends pay for admission? Yes. Plus, 4 friends paid for just the mummy exhibit. Both of these expressions would be fine for starting out. That would be the writing part. This is what we're looking at here. Okay, Brooke?
So we have 6x plus 4y.
Okay, we don't want to combine yet.
Oh.
This is just the writing. That's your simplifying, so we're not there yet. There are two parts here. You have to write the original expression, which would be either this one or this one for your writing. And now we're going to go to okay, so when we go to simplify, let's simplify this one first. What's 4 times x? 4x. What's 4 times 1? Plus 4. What's 4? Oh, I don't need that, sorry. What is 2x? Stays the same. Combine 4x and 2x, we get 6x plus 4. And those need dollar signs because they're accounting for money. So this would be our simplified expression. Okay, or this one here, look at it. Wouldn't this be 6x plus 4 also? Wouldn't I get the same answer? So that's also simplified. These two are exactly the same. So no matter which expression you write, you're still going to get the same simplified expression. Does that make sense? Any questions about how to write that expression or simplify? Feel okay and confident? Okay, let's go on to 497 then. On this page, we just kind of did this on the page before. We're just combining still like terms. Look at example 3. What are my like terms in example 3?
Y.
14y plus 22y. They have the same variable, so they can be added together. 14 plus 22 gives me 36y. I still have this x, which is still there in my expression. So this whole thing would be my simplified expression. Either x plus 36y or 36y plus x. Look at the second one. Now this is just a distributive property. 4 times the quantity, 2x plus y. If I share my 4 times 2x gives me 8x. 4 times y gives me plus 4y. This would be my simplified expression. I can't combine an x and a y because they're different variables. Look at the vocabulary in example 5. This should look familiar. It says to factor. That means to undo. Pencils in hand. Off to the side. Do this with me. Recopy 27x plus 18y. What is the greatest common factor of 27x and 18y? Toby? 9. So we're going to remove the 9. 9 times what makes 27x? 3x. Don't forget the x. Plus 9 times what makes 18y? 2y. If I remove the GCF out in the front, what's left inside? 3x plus 2y. Let's check it and see if it gets us back to the original. What's 9 times 3x? That's what we started with. What's 9 times 2y? 18y. Are we good? So it's just distributing again. Does that make sense? Try it with your partner. Bottom of the page you have these got it problems. Go ahead and do those now. Okay, let's take a look at letter E. What are my like terms in letter E? Toby? 3x and 2x makes 5x plus what's left over? 9y. Here's my simplified expression for letter E. Okay, letter F. We have the distributive property. This means I'm sharing 7 with all my other terms. 7 times 3x? 21x. And 7 times y? Plus 7y because it was adding here, right? There's letter F. Let's go G. We have 12x plus 8y. What's the GCF of 12x and 8y? 4. So this is 4 times what makes 12x? 3x plus 4 times what makes 8y? 2y. If I remove my GCF, I get 4. What's left? 3x plus 2y. Questions? Peyton?
For like, you add,
Uh-huh.
is it fine if you put parentheses around them or not?
We're trying to get rid of those parentheses.
Oh.
Okay, so remove them.
Okay.
The only ones that should have parentheses are the ones that say factor. Okay? Turn the page to 498. We've got one word problem left to take a look at. I strongly recommend that as you're working through problems like these, that we're breaking it apart. Okay, so as we read it, we're going to kind of break this apart. The farmer's market sells fruit baskets. Each basket has 3 apples and a pear. I definitely want to underline that because I need to remember that. Each basket has 3 apples and 1 pear. Use A to represent the cost of each apple. So I'm going to write that right above the apples, so I know that variable goes with apples. Then use P to represent the cost of each pear. So that's going with my pear. Write and simplify an expression that represents the total cost of 5 baskets. Well, first we need to write an expression for 1 basket. What is in my 1 basket?
3 apples and pears.
3 apples and a pear, but we want their cost. So 3 apples would be 3 times A, would give you our cost of our apples. Plus, how many pears? 1, so we just have plus the cost of the pears. That is 1 basket right there. Do you agree that that's 1 basket? How many baskets are we purchasing? 5. So I want 5 groups of that. This right here is the right. Now I need to simplify. What's 5 times 3a? 15a. And what's 5 times p?
5p.
This is money, right? So I need dollar signs. This right here is my simplified expression. Does that make sense for write and simplify? Okay. Are there any questions about how to do that word problem? Did it help to mark it up and write things in there as we were going?
Yes.
Yes. I strongly recommend that you mark up those word problems and break them into smaller sections. Hey.
So we simplify just when you, the outside number just multiply it by all the others inside.
Yep. Just simplifying it to its least amount of terms. Toby?
So you share the 5 with 3, A, and B.
Yep, because it's distributive property again, right? Smashed up against those parentheses. Porter?
So if the number's alone, it's like a 1?
Yes.
Or a letter?
A variable is alone. Yep, it's like having a 1 in front of it. Kind of an invisible one. It's like saying I have 1 orange or I have an orange. Means the same thing. Toby?
How about you can multiply like a variable but you can't add it?
Okay, let me repeat this question. Toby said, why can I multiply with a variable but I can't add? Let's think about this. If I have 5 times 3x, listen, I'm not really multiplying 5 times the x. Okay, but this really means that I have 5 3x's, right? I could write that again like this. Couldn't I? Does that mean the same thing?
Yeah.
Yeah, so these mean the same thing. So really the reason we can multiply them is that you're really combining just the 5 and the 3. You're not really combining with the x. Because think about our commutative property or associative property of multiplication. What I'm really doing is I'm taking 5 times 3 times x. So I'm really just combining the constants. 5 times 3 gives you 15, and we're still taking that times x. It's just we split it up next to it. Does that make sense? So that's why we can, because we're really just combining its constants. Okay? Great question. All right, for homework, what you're going to try for me is page 499. On this page, I want you to do questions 1 through 11, but skip number 10. If you want to try number 10 for an extra credit point, you may. It is a little bit of a bonus question for sure. When you get to the word problems, don't forget you have to write and simplify. The first 6 shouldn't take you very long because it's just simplifying those expressions. All right? You may get to work. That is due on Monday. You also will have your wrap-up, which I'll bring around to you. It is your practice test. Okay, I've also uploaded that practice test to your Google Classroom. If you lose this copy, you could get it off of there. It will be due on Tuesday, but if you want to get started over the weekend, you can. You're probably not going to have much time on Monday because we're going to review for our test. So if you want to start over the weekend, this time around, and this time only, because it's a practice test, you may take it home with you. Okay? You may use the rest of your time to get started today.